All right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump into it. This is finding a formula a sub n for the nth term of the geometric sequence. Oh, geometric this time. Last one was arithmetic, this one's geometric. Arithmetic would be you're adding or subtracting a number every time. Geometric is you're timesing or dividing a number every single time. Okay, so geometric, we're timesing, whose first term is a sub 1 equals 1, such that a sub n plus 1 over a sub n equals 10. I don't like the way they put these. They're basically recursive formulas. They did this on the last one as well. But if I times both sides by a sub n, then I can get that a sub n out of there. And a sub n plus 1 is equal to 10 times a sub n. And that's basically telling me that the common ratio is 10. For instance, let's say n is 1. So that would be a sub 1 plus 1 equals to 10 times a sub 1. Well, we know a sub 1. We know a sub 1 is 1. So that would be a sub 2 equals 10 times 1, which is 10. So if the first term is 1, the next term is 10. All right, well, what would the next term be? Well, that would be a sub, this would be for n equals 2, a sub 2 plus 1 equals, let's do the 10 first, 10 a sub 2. Sorry, so for n equals 2. And so that would be a sub 3 equals 10 times, what's a sub 2? A sub 2 is 10, so 10 times 10, which is 100. So the pattern is we're timesing by 10 every time. It was 1 for the first term, 10 for the next term, 100 for the next term, and you can kind of guess, where it's going to go after that, right? It's just going to keep adding zeros to the number, basically. So we're timesing by 10. That's the common ratio. And so from here, when we build the formula, when they say like make a or find a formula, what they're saying is find the explicit formula. That's sort of like the default one. So if they don't mention what kind of formula it is, they want the explicit formula. So that would be a sub n is equal to a sub 1 times r to the n minus 1 power. And basically the way to remember this formula is if you know the arithmetic formula, you can actually kind of like tweak it to turn it into the geometric formula. And so hopefully you know the arithmetic one because you would have learned about that one first, but the arithmetic formula looks like this, plus and d and then n minus 1. And sometimes the d is on the back end, but I'm going to put the d right here, and that's actually for a really, really important reason. So so here's how I tweak it, right? So like in math, and you actually can't really see all of that. I'm going to move this down just a little bit so you can see all that. There we go. I forgot I was writing on my face, or on my jacket, I guess. So there's this thing in math, right, where plus if you add a number to itself repeatedly, then you're timesing, right? So it's like timesing is like a ramped up version of plussing, if you will. And then if you keep timesing a number by itself over and over, you have powers. Pow. Okay, well, what if we look at the opposite end of that? Like the opposite of adding is subtracting, right? And then the opposite of timesing is dividing. And then the opposite of powers are roots. Pow-roo. Okay, so in an arithmetic sequence, you're adding or subtracting a number over and over and over again, and that gives you your the thing, right? And then you get the formula and all that kind of stuff. Well, if geometric is timesing instead of adding, and we could just say adding, right? Because if you're subtracting, that's the same thing as adding a negative, so we could just say adding. So if you're doing arithmetic, you're adding. Well, if you're doing geometric, you're timesing. So it's like ramped up, right? Like timesing is ramped up from plussing. So what if we ramp all of our symbols up in our formula? Almost all of them. What if plus becomes times? Okay, so a sub n equals a sub 1. And then what if the plus becomes a times? Let me use a different color here. So what if the plus becomes a times? And then what if we use a different shade of blue here maybe? What if the times becomes a power? So then it would be d, but I'm gonna have to rename it here. And then it would be, and times would become a power, right? So like ramp that up, So then it would become a power instead. So it's up here in the power. Now, the only thing I'm not going to change is I'm not going to change the n minus 1, because it's kind of like all together. It's like a grouping. But if I do that, then I basically have the geometric sequence formula. I'll just change d to r, because d stands for difference, and then r stands for ratio. So a1 r n minus 1. So that's one way you can get the formula. That way you're kind of only remembering one formula in a way. So hopefully that's helpful. But anyways, let's jump back into it here. Here's our formula that we would use. And we know that a sub 1 is 1. And then the common difference is 10, which we found out earlier. And then that's to the n minus 1. And then we're basically done. I would just clean it up a little bit maybe and just write it as 10 to the n minus 1 like this. But that's it. That's all I would do. And then that would be the answer. So hopefully that's been helpful. If you think that's been helpful, stick around, because I'm going to make a whole bunch of these. I'm going to do each problem on the day of month that it is. It's April, so we're starting out with all the different numbers. So this is the 8th. I'm doing the 8th. They're all pretty much going to be on the same day, more or less. That's the goal anyways. So keep around, and we'll keep up with it. There's like way more than 31 of these, by the way, but like I think there's only about, I don't know how many there are actually in section 5.1, but that's the section I'm in right now because we're in the beginning stages of this. So stick around, and hopefully these will be helpful for you. And if you want more stuff like this, you can check out other stuff on the channel, of course, but you can also check out my 5 math mistakes everyone makes and how to avoid them. It's a free PDF I have on my website, Myers Mathematics. You can check that out in the description down below, as well as I believe I put my email down there if you have any questions about like tutoring. You can also see what I do for tutoring on my website as well. So you can check out the website for that as well. Yeah, so that's it. I'll catch you guys in the next video. Blessings, y'all.